Hello, and welcome to the Center for Applied Mechatronics here at Alexandria Technical and Community College. My name is Nolan, and I was in charge of the electrical.
I'm Carson, and I was in charge of pneumatic and design.
I'm Nolan, and I was in charge of mechanical design and assembly.
I'm Cooper Olszanowski. I was in charge of programming and automation. And we would like to introduce our project, the pneumatic car.
Our timeline for our project was 13 weeks. 1 week for brainstorming, 6 weeks for design, and 6 weeks for assembly and troubleshooting.
You may wonder where we got this idea from. We wanted to try something familiar, but in a new context. Everyone's seen our normal gas-powered vehicles of every day. You've also obviously seen the self-driving electronic robots used in factories and automation. We want to try something that's neither chemically powered nor electrically powered. This is our pneumatic powered car.
This is the full render of the pneumatic car. As you can see, the two air motors that we have are giving us high speed and low torque. Due to this, we are using a 2-chain reduction. This allows us to have high torque and low speed. As you can tell by the sprockets and chain, this is going to be a set of wheels driven or tank driven. Another thing that you can take away from this is these two mounting brackets that are going to be used for our control panel.
And this is our electrical schematic for the pneumatic car. We got our power supply hooked up to our e-stop and then a fuse protecting the whole system. We have all of our photo eyes for our car. We didn't have enough inputs on here, so we had to put an expansion card to our PLC. We have all of our push buttons and a selector switch in our enclosure, and we have also 2 tilt sensors, one on the X and one on the Y axis. We have 2 fuses protecting 2 solenoid valves.
This is my pneumatic schematic, and we have pressure coming in to a filter, to a regulator that we have set at 80 psi, and a pressure gauge to read that. And it splits off into 2 flow controls, which we have turned down so we can get 16.5 RPM at our motors. And then it goes into another divider and to a 3-2 valve, and then goes all the way through to run the motor, spins the motor, which spins the wheel, and goes to another one. And the way we have it set up here is when this is closed, we're getting the car's just not moving. When this is open, air is going to come through all the way to this one, which is closed, but we have it flipped. So then it's going to just exhaust out, and it's just going to keep spinning. And we can run it the other way by having this one open, it running through to this one, which then we would have this one restricted. And I can show that. On this, I open this, it starts going, it's exhausting. I can switch it, and then switch this one, and then it's doing it the other direction. And so that's pretty much how that works. Yeah.
So, this is the program for pneumatic car. It's on Connected Components Workbench, since we're using a Micro 820. How it works, so the upside of the car is you can change it pretty easily to vary the course you want. How that's done, we have a timer, a retentive timer. You will make greater than less than variables to check your time for, if you move forward for the first 10 seconds, you check. If we're more than 0 seconds and less than 10 seconds in that time frame, you drive forward. This can be repeated as far as you need to make whatever course is needed. And here we also have the setup to implement our manual mode as well for our manual control buttons when you're not running autonomously. And then of course we have our air protection of our front photo eyes, our tilt sensors that are on the bottom and the center of it, as well as our sides to help, if it were to crash in the wall, it will self-correct somewhat. There you go. And here we're going to do a practical demonstration of our project working. First, we'll do an auto mode. As you can see, right now it's pretty simple. It just goes forward and backwards, as mentioned earlier in the program.